Before we get started, I have to tell you about another podcast I love. It's called 20,000 Hertz, and it tells the stories behind the world's most recognisable and interesting sounds. Things like how the sound of slot machines force you to keep playing. Or what the story is behind that THX deep note that you always hear at the cinema. Or could your phone be spying on you through your microphone? Search for 20,000 Hertz, which is all spelled out without numbers in your favourite podcast player.
My mom was on the phone with the doctor. She said, it can't be cancer.
The doctor said you had cancer.
According to the American Cancer Society, 1 in 7 men will get prostate cancer.
Singer-songwriter Olivia Newton-John revealing her latest health battle, fighting cancer for a third time.
Cancer, it's possibly the worst thing you could hear when you go to the doctor. This year, 1.7 million cases of cancer will be diagnosed in the United States, and for around 600,000, that number will be a death sentence.
IBM's Watson may be the technology that helps doctors beat cancer.
But new technology like IBM's Watson computer is helping doctors detect and treat cancer at an earlier stage.
Watson for Oncology can help identify and reduce variability by providing your clinicians with information regarding evidence-based, patient-centric treatment options.
Welcome to Moonshot, the show exploring the world's biggest ideas and the people making them happen. I'm Christopher Lawson.
And I'm Andrew Moon.
And in this episode of Moonshot, we're exploring some of the innovative solutions that doctors are using to help detect cancer and the impact that AI could have on the outcomes for cancer patients.
But before we dive into the details, here's a word from our sponsors.
So there's 4 stages for most cancers.
This is Dish Hayrath. He's a medical oncologist at the Peter MacCallum Cancer Centre and also Western Health in Melbourne, Australia. And he's on the front lines dealing with cancer every day. And a lot of the patients that he sees suffer from lung cancer.
For lung cancer, a lot of patients will present in stage 4, which is the most advanced stage, which generally means for a lot of those patients there's not a cure available, but a percentage of those patients can actually be cured now. So not a large percentage, but some can be cured. Certainly for the earlier stages, there's more chance of cure. So stage 1 and 2, there's more chance of cure. Stage 3 is kind of in the middle. So that's the sort of situation we're dealing with. But unfortunately, we do get a lot of stage 4 lung cancers.
Right now, cancer detection relies on doctors or patients noticing lumps or spots on their body, or they might be found via traditional MRI or CT scans. But unless you've got a reason to believe something is wrong, often you may not even be on the lookout for symptoms that could indicate a cancer diagnosis.
For an external cancer, like a skin cancer, so if you've got skin cancer or melanoma, it's first of all that it's got some suspicious features that make it more likely to be malignant or cancerous rather than benign, and secondly that it's changing over time. Now, if you're thinking about something like an internal cancer, it's very much dependent on where the cancer is in the body and the sort of symptoms it'll present with. So for prostate cancer, that'd be that it might be affecting how men are able to pass urine, how frequently they're going to the toilet. For something like lung cancer, it'll be, are they coughing more? Are they getting more chest infections? Those sorts of things. Now, there are screening procedures for, so if you're talking about prostate cancer, there's the PSA blood test, though that is not perfect. And for lung cancer, there is some work being done looking at screening smokers with CT scans. And again, that's still an area of active research and some controversy, I think.
Medical scans like CT and MRI have made cancer detection far more effective in the past 50 years. They have revolutionised the treatment of cancer and improved patient outcomes, even for the most severe cases. But now there are new ways of using this imaging data to help patients.
Previously on Moonshot, we've spoken about this rise of artificial intelligence in areas like robotics, but it turns out that AI and machine learning techniques can also be applied to healthcare. And specifically, cancer detection makes use of a lot of medical imaging. So there's the potential to use all of that data to train an AI system to recognise patterns and help improve the cancer detection process.
Do you have moles? Most are harmless, but even if just one is cancerous, it can be fatal.
MetaOptima is just one of the companies working at this intersection of AI and healthcare.
Here's how it works. Scan your moles using the MoleScope camera attachment. Use our mobile app to securely share your scans with your doctor. Get an expert's opinion from the comfort of your home.
The idea was how we can bring collective knowledge of thousands of doctors to help with a better diagnostic and treatment decision when it comes to a new case. So it was all about looking at the data, learning about similar cases, and trying to understand and help with diagnosis of these skin disease or skin problems.
That's Maryam Sadeghi, a computer scientist who co-founded MetaOptima with her husband in 2012.
Imagine two computer scientists with training in medical side and dermatology were excited about the future of data-driven, value-driven, dermatology. We said, let's, make it happen. We can build it.
MetaOptima is specifically focused on using AI to detect skin cancers and also melanomas. But rather than giving you an explicit yes or no diagnosis, the AI engine aims to give patients and doctors the knowledge that they need to classify what those lesions actually are.
One of the doctors told me, this is like my intelligent textbook. I was like, awesome. This is the best, simple, brief value proposition that I could actually think for their engine. Because he was like, I go to my textbook, I look for similar cases, but this is like matching images with those. It's intelligent. It can show me, like 100 similar lesions, and sometimes like, is it the same one? It's like so similar. Because this is like simple for machine. It's like pattern matching, finding those cases, looking at the outcome for those cases as well.
MetaOptima has two different branches of their scanning technology. The first is MoleScope, and the second is Derm Engine. MoleScope is targeted at patients. You can use it at home to monitor and track your moles. And Derm Engine is targeted at health professionals.
Derm Engine talks to any other device in the market. Like if you can use any device, any imaging device, any big machine, we connect with those systems and give you centralized access to basically to the data to the patient side you have on the physician side. On the patient side, we actually decided to have affordable devices for them to be able to capture quality data. If we are talking about empowering patients with AI, they need to have also the right tool to be able to give the quality medical data to the system, to the AI that can help them.
Essentially, the main aim for the company is to incorporate artificial intelligence into the workflow of diagnosis, rather than actually replacing the doctor. And Maryam says the reason for this is because AI systems, while they can be fast at doing tasks like image classification, when it comes to something as serious as cancer, you don't want any room for error. So you don't want to put too much reliance into an AI system unless you can prove that it works all the time.
This is not Airbnb that, you can have like disasters, but at the end it's like just money. It's fine. This is like patients' lives. This is very different.
Now, AI isn't limited to any particular type of cancer detection. So while MetaOptima is specifically looking at skin cancers, which are very easy to see and take a photo of, other companies are taking on the task of identifying cancers that lie within.
So we looked around at a number of different cancers, and we found that prostate cancer has, number one, it has a lot of medical imaging in its pipeline, but that medical imaging has really only been taken up in a big way over the last sort of 5-ish to 10 years. And we felt that there was an area here where we could provide a lot of benefit.
This is Elliot Smith. Elliot is the co-founder and CEO of Maxwell Plus, a company which is using AI to help detect prostate cancer in men.
Prostate cancer affects a lot of people. In Australia, it's roughly 1 in every 7 men will, at some point in their life, generally much later in their life, sort of 50 plus, will develop prostate cancer. So we felt that it was an area where our technology could be applied, but also where there was a need for some new technology to really help ensure that people were getting diagnosed early and treated in a low risk and effective way.
In a similar way to Meta Optima, Maxwell Plus is building tools to help give doctors more confidence in the decisions they're making. The company has started with prostate cancer, but they're also working on the detection of lung and breast cancers.
As we've talked about on Moonshot previously, the quality of an AI system is based on having access to really good data. And when it comes to diagnosis of patients, it's even more important that the AI is fed good quality information. But how much data do you actually need to make the system work at a level where the doctor could feel confident in the decision that they were actually making?
As a general rule of thumb, you'd want about 1,000 cases in each of the different categories you want to classify between in order to start to see some good results. So in our case, if we simplify the problem a little bit down to yes cancer, no cancer, we'd want about 1,000 in each category. And then from there, that's going to give you early indications of results, but it's probably not going to be human levels of performance.
Now, Elliot says that as you try to improve the AI system and reduce the error rate, it requires a lot more information. Every time you halve the amount of errors in the system and therefore improve your cancer detection accuracy, you need to provide 10 times the amount of data that you previously had.
So let's say we started at 80% with 1,000 in each class, and we wanted to get up to 90%. As a rule of thumb, you can imagine that we'd want to get to about 10,000 in each class to reach that 90% mark, and then 100,000 to get up to around 95. So, there's definitely a huge amount of data that we need here. And when we're talking about 3D scans of patients, their genomics and their blood work, every single example that we train on can be in the sort of tens to hundreds of megabytes range that needs to be processed through this algorithm.
And we'll continue our look at the use of artificial intelligence in cancer detection right after this break.
Welcome back to Moonshot, I'm Andrew Moon, and when we're talking about cancer, it's important to know how cancer cells actually work in the human body. In a healthy body, cells grow and multiply in a controlled way, following genetic instructions to make sure everything is in the right place. However, cancer is caused by a defect in these genes.
This defect prompts an uncontrolled growth of cells. Some types of cancer stay in one location and grow slowly. However, malignant cancers are aggressive, and they can spread quickly to other parts of the body, making them much harder to treat. The complicating factor is that cancers can actually present differently in different people from different populations, which Dr. Hayrath says still leaves a big question mark over the effectiveness of an AI system when trained on any one population's data.
So something like the US and Australia would be much more comparable in that regard. I think where you're going to see some pretty big differences are places like Japan, where they have, a very ethnically homogenous group of patients who are quite different to Australian patients. So we're probably more comparable to somewhere like the US than to Japan, for instance.
So any systems that are detecting cancers would need to be trained differently for like a Japanese patient compared to an Australian patient?
That's a great question, which we don't know the answer to yet. So, and again, this is why I would say the way to do this is to actually look at the performance of the systems in the real world. It may be that you don't. It may be that you don't need to train it on different populations, that it can get enough information from, a US set of patients that it can then more broadly applied. But we shouldn't just take that at face value, where we just drop in the US system and start using it here. You actually have to test out whether that is working in a real-world environment in Australia.
Detecting cancer early is one of the keys to successful treatment, and it's hoped that using an AI system will alert doctors to potential cancer faster and help them start treatment earlier. Another benefit? These systems could have a knock-on effect by helping doctors become more effective with the resources that they have.
There's a number of factors here. One is that if you look on a global scale, there is a shortage of doctors worldwide. And, some countries have it a lot worse than others, but even if you look at parts of the US, there are certain states where they have around 50% of what their projected need for clinical expertise is. So there's certainly a need for more clinical brain power. But also, as we try and detect these cancers earlier and earlier, the signs of the cancer being there become more and more subtle. And we need systems that are able to look across complex relationships between data that aren't apparent to the human eye and reshape those in a way that helps clinicians understand that data and can perform that earlier diagnosis. Because as they're small and harder to detect, we naturally need better and better tools to be able to find them in the first place.
The World Health Organization estimates a shortage of 2.6 million doctors worldwide, mostly in developing countries. And with such a huge shortfall in the pipeline, it makes detecting cancer at an early, low-risk stage in the traditional way a pretty difficult job.
So our goal is to get there when it's very early signs of cancer. So for prostate cancer, it can be a slow-growing disease in some people. In others, it can be quite rapid. Sometimes it may take 3 to 5 years in order to develop into something serious. We want to catch it when it's at that first sign. Now, that doesn't necessarily mean we're going to go in and do surgery right away, but if we know it's there and we can monitor it, we can work with the clinicians to pick a time to intervene when it's going to be most effective in terms of stopping the cancer, but also pose the lowest risk.
Elliot hopes that with more information, patients can make better healthcare decisions on their own. Instead of a single doctor planning your treatment, an AI system would work alongside healthcare professionals to shape the course of a patient's long-term health.
Yeah, we believe that in the future, patients will have much better control over their healthcare. There will definitely need to be more information given to patients to help them understand what this data means. We don't want this Dr. Google scenario where people look up their symptoms and cause themselves all sorts of worry. But we think that with the right access to data and the right access to patient education, we can really turn healthcare from what it is today, which is a very reactive system. You get sick, you go in, you try to get better, to something that's much more proactive.
But despite the progress that is being made in trying to improve the accuracy of these systems, Dr. Hayrath says it could take a while before AI becomes reliable enough to be considered useful in the fight against cancer.
So the first thing I'd say is I think that this is actually very exciting because it has the potential in the future to help patients. So that's the number one thing, that doctors would be focused on. I think that in terms of where the companies are at the moment, I think this is still very much in the research arena. I'm aware that there are companies that are marketing their products, for clinical use. My personal feeling is I don't think that for many of those that the enough research has been done to show that there's benefits to patients, which would make that worthwhile at this stage.
One of the other concerns that many have when they hear about AI moving into an industry is what will happen to the jobs of those already working in it.
I think if you think about the broader medical community, there are some fears around this, the kind of impact on their jobs and either changing their work roles or in some cases potentially replacing them. So I think, my feeling is I don't think that doctors are going to be replaced anytime soon by these sorts of technologies.
But change is inevitable. We've seen that in many industries as technology advances, and when it comes to healthcare, medical imaging and technology has already revolutionized cancer detection and treatment, improving patient outcomes and saving lives. Artificial intelligence could yet again redefine healthcare as we know it. And while it may take some time to work out all the bugs and make it reliable, it's up to the healthcare industry to embrace these new systems and not to fight against them.
I think that healthcare workers and working together with these technologies will be more powerful than the technology competing directly with a healthcare worker. So that's the way I see it. Having said that, I think that it's highly likely that in many industries, changes will need to occur in terms of how you do your work, workflows. I think that that's extremely likely. So the areas I would see that as, the first areas that would see that happening are things like radiology, where people are looking at scans and x-rays. But to be fair, these are guys who've had many disruptions in their careers already. Things change very quickly. There's new technologies like MRI. Even within the space of my career, things like MRI have come in. So I think people shouldn't underestimate the ability of the people who work in these fields to adapt to change.
I believe it's very, very important to help with implementing AI to have impact in our everyday life. Is that to understand the limitations and to understand the requirements and to understand the safe implementation for the technology to help us. I don't think we should expect things that are not reasonable and it's not fair, really. And on the other side, we shouldn't fight it.
We've set ourselves a goal over the next 5 years to try and bring artificial intelligence-based analysis of medical data to 1 million people around the world.
This is Elliot Smith again.
It's a big goal, but really that's where we hope to get. We want a technology that's accessible, that's affordable, and that's widespread enough that we can make sure that the best in class in analysis of medical data is made available to all these people, so that no matter where you are, you have the very best in diagnosis and very best in screening made available to you.
Thanks for joining us on another episode of Moonshot. Moonshot is a production of Lawson Media and it's hosted by me, Christopher Lawson, and also Andrew Moon. Research for this episode by our intern, Caroline Ho. Additional production by Julia Pillai. Additional research and scripting by Mahalia Carter and Patrick Laverick. Our amazing cover artwork is by Andrew Millist, and our theme music is by Breakmaster Cylinder. If you want to get in touch with us about the show, you can send us your feedback or ideas to moonshot@lawson.media. We'll be back again next week on Wednesday with another brand new episode of Moonshot. So make sure you're subscribed so you get the latest every time we publish. Before we go, I just wanted to remind you to subscribe to 20,000 Hertz. It's a fantastic show about the things we all hear but don't really think about. They cover everything from the beeps and bloops on our devices to iconic sounds like the NBC chimes. Subscribe in your favourite podcast player by searching for 20,000 Hertz, which is all spelled out without any actual numbers. Again, that's 20,000 Hertz. I'll also put a link in the description.